Hi, the lecture on Chapter 10, approaching the end. We only got Chapter 10 and 11, and then on to the final. So this one is actually the application. We're at the top of the OSI layer, OSI model, layer 7, all the way to the top. We'll talk about some of the key applications. So in this, we'll look at the different protocols that support the application. We'll look at well-known applications and services and which ones that you really need to understand and know. Some of these DNS, DHCP, how to transfer files, web, email, all of these are key major ones. So let's look at some of these application layer protocols. So like I said, we're at the top of the OSI application layer, top of the 7. As far as OSI concerned, if you're using the TCP/IP model, it's just one segment of the application layer. And in that, you end up having a number of different applications that come into play. One you've used a lot as far as ping, DNS. Some of these you haven't used, and you're going to use in the homework. You're going to use file transfer, and maybe one other one you use. But this is a part of the application. It's the closest to the user. It's between the user and the application as far as the type of data that you're going to be sent. Now, you also get, because we're looking at the TCP/IP model, and it groups 3 of the OSI layers. You also got the application, presentation, and session layer. Now, presentation says, how's the data going to be formatted? How's it going to be at the source? Whether it's JPEG or MPEG or PNG type file. Then you go down to the session layer and says, okay, that's where I'm going to worry about maintaining dialogues between the source and destination application. So, but as far as the TCP/IP model, all these are rolled into one layer. Now, some of these protocols you've used, and the things you want to make sure you understand is, one, you want to make sure you understand what category they're in. So when you look at each one of these, you're going to say domain name server. You're going to look at which transport layer is used and which port number. So you're going to make sure you understand that. And, of course, the definition of which ones it does. So you got DNS, the boot protocol. It's an older one. It preceded DHCP, not used that often. You got the DHCP, which you probably use a lot at your home, and at school you use a lot. But now it's a UDP client, but it uses a couple of different port numbers. You've got simple mail protocol. You've got your POP protocol, which now it's going to retrieve it from the server. Now, most email servers nowadays are, at least Google and stuff, it leaves it on a server, and you just retrieve mail there, and it stays there. Now, we've seen this gives you retrieves email from a mail server. File transfer just allows me to transfer it. It's a reliable, connection-oriented. So what am I going to do? That means I'm going to have session initiation, startup. So if I want it reliable, which protocol transport layer? You can use TCP. It's got 2 ports, one for controls, one for data. We'll go a little bit of that. I think one of the labs, you're going to use TFTP, trivial file transport, and you're going to use FTP. I think those are the 2 for the lab you're going to be playing with. And of course, you've used in your real life HTTP and HTTPS applications. Now, how are these supposed to be working? Well, guess what? We're working on a client-server model. Client is usually your PC, your handheld, and the server is some other machine, some other computer, someplace else that stores a lot of information that will interact based on your requests. So basically, the application layer describes the format of the requests and what kind of responses are going to be between the client and the server. So here you get a couple of examples. Email is probably the biggest one. So now in some networks are peer-to-peer networks. Okay, you had the client server, peer-to-peer, but as you can tell, there is no server between the two. Each device is known as a peer, but guess what? If I want to print something, peer 2 is not working or not up. Do you think I can print? The answer is no. So there are some drawbacks to a peer-to-peer network. Some of the applications, what do you think here? I got P2P, I got peer-to-peer application, allows devices both as a client and server at the same time, but it requires that each end device, kind of run in the background. So what do you see? I'm seeing some text messages could be a peer-to-peer network. Now, some of the common peer-to-peer, G2, Bitcoin, BitTorrent, all of these are ones you've probably heard of Bitcoin more than anything else. But guess what? It just allows me to, it's based on a protocol. I couldn't even pronounce that. GUNTLA. Yeah. GNU-TELA. Maybe. As far as the application that's used to share the file. Now it just allows me to share pieces of information of many files, so that you just kind of play it again. Now you're not going to do any peer-to-peer file sharing in the lab, but just know that they're there. Now some of the well-known application layer protocols and services, we mentioned them briefly in the previous section, but probably the one you use the most is, HTTP. So you get a web page, so you get a response, so you got a URL typed into a browser connects to and see that HTTP when you look at your web, next time you're on Google, check what you see. You're going to see HTTP. You're going to tell which protocol am I expecting to run on the client. So I want to type in a client, it's going to give me access to this server, and it's going to tell me which protocol am I going to plan to use. Now you got two different protocols. Here's HTTP. You got the URL. It's making a request, and it's actually requesting what? I'm requesting a particular file from Cisco. Now in this case, it's going out and getting an index file which lists all the pages that Cisco has, and it's using the get command to do that. So usually some of the common ones you're going to see, I'm going to make a request, I'm going to put things up, I'm going to post it, and I'm going to upload data to it. So I'm going to use a get, post, and a put as far as making requests to my HTTP server. If you want to use a secure version, which if you hopefully you're using your bank has an HTTPS, and that uses encryption and authentication, and usually a third-party authentication service that they're paying to make sure you are who you say you are. Now, email protocols, there's a couple of different ones. There are 3 of them. And basically, it allows me to get information to and from email servers to your PC. There is a simple mail transfer protocol, and that's used to send email. But there are 2 emails protocols they use to retrieve email. There's a POP email protocol and an IMAP protocol. Now, POP says what? I'm going to leave information. You're just going to retrieve it. So here's the operation. SMTP, as far as sending email, goes to the server, said, hey, I'm sending it to a particular forward. Now on POP, I'm going to use to retrieve email from a mail server, but here the email is downloaded from the server and then deleted on the server. So some email services do not keep the email on the server, and POP it is. And now I think POP 4 is probably the latest and greatest. I mean, POP 3, I guess. Well, in this case, it's POP 3 was the time this was created. But I don't know how many actually use this, because I don't download all my mail all the time, because I'm on different devices and I don't want to have to retrieve and have everything stored or keep that same device. So I usually will most of the ones that say, hey, I'm going to retrieve email from a mail server, but it copies the messages downloaded, and then so I get a copy that I'm looking at, but I also have the original one, so that I still have opportunity to go back and look at it, organize it, delete it, whatever, clean it up. So most of your applications today, probably Google Mail is an IMAP protocol. And I think one of the ones you're going to do, I don't think I actually had to trace, maybe I did have to trace email. Now, domain name service, you guys have used it. And basically all it does is convert numeric address. The numeric address is what? The IP address. I'm going to take an IP address into some kind of recognizable name. So basically DNS defines an automated service that matches name to the IP address. Now the format of this message, I've got a header, question, answer, authority. So it's basically, I'm going to try to figure out what name I'm going to associate with a particular IP address. So what a server does is, hey, when I might pick a client, I want to take the DNS process, first looks at its own records and say, can I resolve the name? If I can't, it's going to say, it knows other servers that at a higher level, it says, hey, I'm going to forward it on and see if they can resolve that address. So, and once I do that, once I get an address, the server's going to store it temporarily. Even your PC will store it temporarily, so that if you use that name again in a recent, in the near future, it doesn't have to waste the time going up and looking for that file. If you're checking your PC, you can do an ipconfig splash display DNS. Will show you all the URLs and IP addresses that your computer knows about. It gives you a rough idea of the different hierarchy. So you got secondary level domains and top layers. So when you see these .coms, .org, .edu, those are top level domains, which allows me to go get more information about these engines. So just keep in mind, client, secondary level, top level. Their DNS has this hierarchy, so I'm not always having to go all the way to the end to get the final record, the final IP address and name. I can go just as far as I need to get the information. If I don't have it at any one, if I don't have it at the secondary level, I go to the top layer to get it and move on. Hi. Now the NS lookup, I had to take a little bit of break there. It's a command on your computer that usually manually query the server for given hosts. And it could be used to troubleshoot resolution issues. I don't play with it too much, so it's one that's not new. But you can basically say, okay, which ones do it knows about it. It kind of tells you which server, which IP address on your PC. Now, DHCP, we've talked about, you've used it. You haven't really set one up, but basically it basically automates IPv4 address, subnet masks, gateways, DNS servers. Now, DHCP addresses are leased for a period of time, so you only borrow them for a short time, and then once that lease expires, it's returned to a pool of addresses. DHCP for IPv6 is the same thing, but it basically means that your server says, hey, I'm going to give you an address, I'm going to lease you an address, an IP address, for a period of time, and keep track of that lease period. When it expires, I remove the lease, and then next time you log in, it will then reestablish, try to find a connection, and get a new IP address. Now, the steps in this operation is DHCP discover, DHCP offer, DHCP request, and DHCP acknowledgement. What I use to kind of remember those steps is, remember the movie Dora the Explorer? guess what? DORA. Discover, offer, request, acknowledge. DORA. So just shows you the different steps in how this is supposed to take place. And you're going to do a little bit of a lab on this to kind of understand how that all comes to play. DNS. Now, file transfer protocol basically requires two connections between, because I'm going to send data between a client and a server. I've used to transfer large amounts of data to a host machine that I'm out working on. I'm at my office, but the customer's location is in Timbuktu. But I can email the data file, a new program, a new operations file, and but I don't need to email it because I'm working on a manufacturing location. So I just have a IP address of that machine, and I want to upgrade it. But what this requires is two connections. It's got a data connection and a control connection. So you've got your control informations on TCP port 21, and the actual data is going to be on port 20. So just know that FTP is one of those that requires two ports. It uses TCP, so what it tells me that I'm going to have a three-way handshake, and I want to make sure I've got a reliable communication. Now there's one system for file. It's called Server Message Block, SMB. It's another file sharing protocol. And I think you're going to do that with an FTP. You're going to do you're going to do a web-based version of it, and you're going to use a command line version of it in one of the labs. And SMB is just a way of being able to copy data between those two, at least to share files. That's the FTP lab you're going to do and explore that. So hopefully this chapter, as far as applications, there's a few key applications that we do that we use a lot. You haven't been exposed to as many. The biggest ones you probably used is, in this case, you use what? I've used the application ping. We've used DNS, and we've used HTTP and HTTPS, not necessarily in class, but necessarily in your public life. So hopefully this gives you a rough idea of everything that we're going to cover in this chapter, and look forward to seeing you next week. Bye-bye.